The evolution of programming functions. A procedure is just a top-to-bottom sequence of operations. In this simple example, the program consists of 4 operations in sequence. First, there's operation 1, operation 2, operation 3, operation 4. At the assembler level or machine code level, we call these operations opcodes. Subroutines are used when there's multiple procedures that contain duplicated code. We could grab the code, operations 3, 4, 5, 6 in this diagram, and move them down into subroutine and share them between the 2 procedures A and B. To do this, we insert a call instruction in the procedure and a return instruction at the end of the subroutine. So when procedure A wants to perform steps 3, 4, 5, 6, it does operation 1, operation 2, suspends operation, calls the subroutine, then runs 3, 4, 5, 6. That returns back, it unsuspends, and then it continues on doing operation 7 and 8. Likewise with procedure B, does 9, 10, suspends, calls the subroutine, does 3, 4, 5, 6, returns back, unsuspends, and does 11 and 12. To do this, note that we've had to add a memory cell that memorizes a bookmark and lets the subroutine understand where to return back to. Note that this return address is a single memory cell. We could use a register to point to it, but it is simpler to use a label. We're not using stacks yet. When we get to stacks, we're going to need a register. As a first step towards building functions using subroutines, we figure out a way to send a parameter to a subroutine. First, we need to bind the parameter before the call in both cases. And in this very simple case, we just use a non-reentrant memory location, a cell, and we just stuff a value into that cell. Later, we'll develop a reentrant way to do this. Here, the subroutine needs to fetch the parameter so that it can operate on it. The next step is to figure out how to return a value from the subroutine. Here again, we use a memory cell for the return value. We stuff it at the end of the subroutine and fetch it after the call. To allow for recursion, we need to prevent overwriting parameters, so we use a stack of memory cells. Here, we probably want to use a register and auto-increment and auto-decrement to make things faster, instead of using several opcodes to operate on the stack. Likewise for return values. We put it all together and we get reentrant parameterized value returning subroutines. We call these things functions. We might be able to optimize away the bind and fetch operations, but we still have a stack of memory cells and a stack pointer register.